Before diving into linear algebra, let's think about how we want to derive the linear equation shown in this figure. It is useful to begin with what we know or observe. Obviously, we have access to the data matrix, that is, values of yi and xi in our example with one explanatory variable. We can write the linear model as follows, where epsilon I is the error term. The two coefficients, alpha and beta, are unknown. How can we derive optimal values? And what does optimal mean in this context? Put differently, what is our objective function? What do we try to accomplish? Fundamentally, we have to ask ourselves, how do we quantify the error? And there are many different options. For instance, we could focus on the average mistake we make. But in this case, how do we deal with positive and negative values? We might over or understate the dependent variable y. Then we could consider taking the absolute value. We could also focus on the maximum mistake we make. We could also take the squared error, which would penalize large deviations, large mistakes more. Finally, how should we aggregate the error measurement? We don't want to just focus on individual measures. How can we combine them? Should we simply grade the average, or should we take the sum? We need to decide basically on the so-called loss function. At least the objective should be obvious. We will try to minimize the loss function. In the case of OLS, the loss function refers to the sum of squared residuals. Now, what are residuals? So when we go back to this equation and rearrange this equation, we obtain the following. In that case, we define residuals as the deviation of the observed value of a dependent variable from its predicted value, where alpha and beta hat refer to our estimates. To be precise, these are so-called point estimates. The symbol hat indicates an estimate. Hence, the residual is an estimate of the unobserved error term. Finally, our objective is to minimize the sum of squared residuals by selecting the coefficients, the alpha hat and beta hat. We can write this as follows. So this here is our minimization problem. In the next session, we will try to find an analytical solution to minimize this loss function. I see you there.